Okay, so if we put a half in front of x this time, what do you think is going to happen to it?
It's going to stretch out.
So how much?
By a factor of 2.
And you are absolutely correct. So let's take a look. If I put a 1/2 here, okay, the graph just got twice as wide. Okay, so it's a little bit trickier working with the x value. This time when we look at the graph, for example, if I was at 2 here on the old graph, that means on the new graph I'm going to be at 4, which is double. So I end up over here. So horizontally, everybody has jumped by twice as what they used to be. So here's the graph. It would look about like this. So again, if I was to start with x equals 2, to get the same value out of this, I'd have to put in x equals 4, twice as much, because now I'll be at half of 4, which is 2, where I started. Okay, so it's a bit of a brain buster. The quick and easy way to remember it is we're dealing with reciprocals here. The reciprocal is 2. The reciprocal here would be a half. So we're always dealing with the reciprocal in order to describe a horizontal transformation. Okay. So if we're dealing with a fraction, that's actually going to expand our graph. It's going to make it bigger this time. And if we have a number that's, say a whole number or something bigger than 1, then we're going to end up shrinking our graph or compressing it like we did in this one. So this one has now become a compression. So you can probably guess what b is known as. Can you, if the other one's the vertical stretch factor? Yeah, the horizontal stretch factor. So again, you can abbreviate this HSF as in the horizontal stretch factor. And the value of it, again, it's trickier to come up with. You have to remember this little rule that when you do a horizontal compression or expansion, you use 1 over the horizontal stretch factor. 1 over b, sorry. Okay, so let's just see who's confident about what they've got here. And I know it might be tough for us right now getting a hang of this one, but where's the point xy if I put a b in front of x here? Where is it now located?
1 over.
Very close.
1 over bxy.
1 over bxy, right? It's going to have to take the reciprocal first, and it does not affect the y-coordinate. So when we're trying to map out points, that's what happens is we have to use the reciprocal to figure out where the x-coordinate is. Okay. So like in our first 2 examples here, right? This was a 2, but it ends up squishing everybody in by a half. This is a half, it ends up stretching everybody and doubling all those values. Okay. So we'll try a couple and then it'll kind of sink in a bit more. Okay. The best way to think about these ones, I don't think it's super clear in the notes. This should be y equals 2f 1/2 x, and this should be y equals 1/2 f of 2x. And this graph you're looking at here is y equals f of x. That's probably the clearest way. I think I made a typo when I wrote it in the to do that graph. Okay. So I'm going to let you do these 2, but we're going to talk out the first one before it happens. Okay. So what has happened in this first transformation right here. Can anybody give me one hint about how the graph differs from the original?
I think the what? The one on the left or the?
Yeah, this one here. How much is? Just give me one thing about it. How would you say that's math, right? How would you say it in English? What's going to happen to it?
It's going to turn purple.
I might draw it in purple. It's gonna be stretched by factor 2. You're correct. In vertical, okay, yeah. So the vertical stretch factor, and we'll write this in the margin when we do our work. Vertical stretch factor equals 2. What's the horizontal stretch factor going to be? Yeah, it's also going to be 2 because horizontally we have to take the reciprocal. So horizontal stretch factor is also equal to 2. Okay, so let's do one of these points, and then I'll let you finish the graph. Okay, so let's do this one here. This is the point -3, and I think it's 1. There's 2 tick marks on that graph for each.
Joyce?
Uh-huh.
On the notes here it says, is the one at the top there is the sign of pi x over 2.
Yeah, there's a typo in there. I needed to make a couple quick changes to that, so I apologize. What you should do is think of it as these 3 here. Okay, so
So I'll just change it to 1.
just write it as y equals f of x is this, and then y equals 2f of 1/2 x, and then this here. Okay, so let's just do one point together just so I know you're on the right track. Where will this point end up in this new graph? Steve-o. Where do you think that point's going to end up? You're correct, yeah. Say it like you mean it.
-6, 2.
Yeah, that was pretty convincing. So you're right. They're going to be doubled. Double the horizontal, double the vertical. So this point will now be at -6, 2. So I go over to -6 and up to 2. This is where I should expect to see it on the new graph. Okay, so you try and finish that one, and we'll recap together. Okay, so if you're not quite finished, that's okay. I'm just going to try to catch up to where you are. So this one should be at... let's see here. So the first one, go back to 4, 0. Down at... this point here is at -1, -1, so it's going to be at -2, -2. There's another point, it looks like it's at 1, 1, so that'll be up at 2, 2, and 3, 1 is now going to be at 6, 2, and last one will be up here. Okay, so we'll start over here. So hopefully you have something that looks like this, a graph which I can't really quite fit them on, kind of can fit them, but twice as wide and twice as tall as the original. So likewise for the second one that we've got here, can someone just in English explain what this graph is going to look like? If this is the math that you've been shown here, how would you describe this in English? Sorry, say it a little louder.
Half the size.
Half the size. Keep going, you're right.
Both the horizontal stretch.
Horizontal stretch and vertical. Okay, so this time when you map your points, if you haven't already, they need to be halved on each coordinate, and you're going to see a very small graph come out of it. Yes, question?
I have a question. Is the VSF and the HSF always equal?
No, it's always, this is the value here which dictates the vertical stretch factor. And this is the reciprocal of the horizontal stretch factor. So it just so happens that in those examples I've picked, they are the same, but the next one you'll see they can change. Okay, so I'll map these ones out fairly quickly. So it looks like one of them is here, and I believe so I think well, maybe I'll try and do a better curve. Nope. One more time. Well, and again, if you compare it to the original, it is half as wide and half as tall. Good. Okay, so your turn now. These ones, the stretch factors are not the same. So what I want you to do is map. This is more typical of the kind of figure that you'll end up with encountering on your exams and things in this course. So take the stick figure and see if you can apply those transformations, and see if you can come up with the rule for a point that has both compressions and expansions on it. Okay, so again, you only need to use as many points as you feel like will give you a good hint. So I'll probably map these points here. So now that I label my points, I have to be able to say in English what's going to happen. So can somebody say quickly for me in English what's going to happen here in this first transformation?
Well, you get taller and wider.
Taller and wider. Can you be more specific, Anthony?
By twice as much in both cases.
Great, thank you. The horizontal stretch factor is? Careful, right? It's a half. When you do horizontal, it's always going to be the reciprocal. So in this case, it's actually twice as tall, but half as wide. So it's going to be a very narrow but a very tall version of what you've just seen. Okay, so here we are at 2 then. Then we're going to be at, instead of at 2, that point's going to jump all the way up to 4. So it should look about like this once I double them up. So 4 will be 8. And 4 negative 2 is going to be 2 negative 4. So my best rendition, which is half as wide but twice as tall. Okay, and then this one here, what would we expect in English to happen for this transformation? Half as tall and twice as wide, that's correct. So here is my vertical stretch factor, so VSF equals 1/2, and horizontally I would expect to see this graph double because I'm going to take the reciprocal of the 1/2. Okay, so that means the points are going to be much wider but much shorter. So it'll be at 8, 0 still. Then instead of being at 2, it'll be at 4, 1. Oh, sorry, that's not 8, that's 9. Then it'll be at 0, 1. And it'll be at, let's see here, 2, 2. And it'll be at 8, negative 1. So the graph has been squished, and the graph has been stretched wider. So how could we describe this here? If x, y is a point on the graph, then what will be a point on a f of bx? Where will I expect to find it if this has happened? How do I map the coordinates? I'm going to look at the west side. Hang on, there we go. The west side. Okay, west side people, step up. Let's see who can help out your west side members, your west side homies. I grew up in the 90s, so what can I say? Awesome, thank you, Robbie. So 1 over bx, ay, is where we'll expect to find those coordinates now.